Hello and welcome to another STEM lesson. This week we're going to be discussing rocks and beginning the rock cycle as well. We see rocks outside every day in both landscaping and nature. In fact, the entire Earth is basically one giant rock. The Earth's crust is entirely made of solid rocks, so there are huge rocks in the ground covering the entire planet. We cannot see many of these rocks. Sometimes dirt covers them and we must dig very deep to find them, but huge rocks cover the entire Earth's crust, even under the oceans. That means that all of our buildings, all of our bridges, all of our roads, and even your home are sitting on rock. Geotechnical engineers understand what causes rocks to break. They know how to identify different types of rocks and determine if a certain rock is likely to break. They work with structural engineers to plan the best way to build structures in different types of rock conditions. So how do rocks break? When pressure is applied to an area, such as a rock, it is called stress. If you press your hands together, you can feel the force of stress. Now, in nature, stress can cause rocks to break, and one way that stress occurs is by the natural movement of the Earth's crust. Remember that the Earth's crust is basically floating on liquid magma, so it moves very often. These are the types of stress. Compressional stress is when a rock is pressed together into itself, like when crust movements cause two rocks to squeeze another one between them. Another example is when mountains are formed at a convergent boundary, like the Rocky Mountains. So press your hands together, and you can feel that the inner part of your hands are being smashed by compressional stress from the muscles in your hands pushing inward. Tensional stress is when a rock is pulled apart. For example, if a rock wedged itself into the crack of another rock, and movement of the Earth's crust caused it to wedge even further until the rock broke apart. Now use one of your hands to pull a finger on your other hand. You can feel the tensional stress because your hand is pulling your finger one way and your other hand is attached to your finger, pulling it the other way by holding it in place. Shear stress is when a rock is pulled on one side but pushed on the other side. This can happen if the crust movements on one side of a rock are opposite of those on the other side of the rock. An example of this is the San Andreas Fault, which is on a transform boundary with the California plate moving southward and the Pacific Ocean plate moving northward. Again, put your hands together, but this time press upward with your right hand and downward with your left hand. So if you press hard, you should notice that the skin on your right hand is being pulled down because of the forces from your left hand pulling down, and the skin on your left hand is being pulled up because of your right hand. In addition to stress due to the movement of the Earth's crust, stress can come from weathering. Weathering is the breaking down of rocks into sediments or small bits of rock due to conditions in nature. There are many types of weathering, such as physical weathering, which is when a physical action breaks the rock, such as the forces of wind or water. A common example is the freeze and thaw action of water in rock cracks. As the water freezes, it expands, causing stress or pressure that breaks the rock. Chemical weathering is when the rock is chemically broken down. Some common examples of this are rust forming on granite or acid rain breaking down limestone. This type of weathering is not considered a type of stress because there is no pressure on the rock. Biological weathering is when living organisms break the rock. A typical example is a tree root breaking the rock due to stress caused by its pressure. So what makes up rocks? Knowing what makes up rocks might help us understand their strength. Rocks are made of minerals. They are classified into different types depending on their mineral composition and formation. First, we'll talk about minerals. A mineral is a solid material that exists naturally on Earth and is made of only one substance. Most minerals are made up of crystals, which are solid 3D patterns made by molecular structure. There are hundreds of different minerals, and they are classified by their chemical makeup and crystal shape. Some familiar minerals include gold, silver, diamonds, and quartz. Minerals can be identified by conducting a series of tests and comparing the results to charts of known mineral characteristics. The tests include finding their color, streak, which is the color of the mark they leave when you rub them on something, the transparency, hardness, luster, which is how they shine, the cleavage, that is specific way that they break, and their crystal shape. So what's the difference between a rock and a mineral? Rocks are made up of two or more minerals. For example, granite, a very common rock, is made of minerals feldspar, quartz, mica, and hornblende, which can be seen in the granite. Now let's discuss how rocks are made. Besides its mineral components, a rock type is also determined by the way it was formed. The three basic ways that rocks are made are grouped as the three rock families: sedimentary, igneous, and metamorphic. Sedimentary rocks are made of sediments, or small bits of old rock. Sediments come from the weathering and erosion of old rocks. Weathering is how rocks are broken down, usually from influences such as water and air. Erosion is the breaking down and movement of parts of the Earth's surface. Once sediments are broken apart from weathering and erosion, then pressure pushes them back together to make a layer of rock. This is called compaction. Cementation also holds sediments together, which is when salt crystallizes as water is squeezed out. Later, other sediments get pushed into another layer of rock, and eventually the layering or bedding continues to make one bigger rock. This process creates layers that are characteristic to sedimentary rocks. Some common sedimentary rocks are sandstone, siltstone, limestone, conglomerates, and shale. Igneous rocks are made of magma, which, as we've learned a few weeks ago, is molten rock. Magma is called lava after it comes out of the crust, for those who might have forgot. When the liquid magma or the lava cools, it becomes hard, forming an igneous rock. The name igneous comes from the Latin word ignis, which means fire. Different types of igneous rock are formed if they cool slowly below the Earth's surface, called intrusive, or quickly above the Earth's surface, called extrusive. Some common igneous rocks are basalt, granite, pumice, and obsidian. Okay, the last group is called metamorphic rocks, which are formed from any type of existing rock. Pressure and heat change the actual molecules of a rock's minerals so that it becomes an entirely different rock without melting, which would have made it an igneous rock. The type of metamorphic rock formed depends on what type of rock it started out as. Folation is when the pressure squeezes the minerals in a rock to create lines or layers. Folation is the typical metamorphic rock characteristic. Some common metamorphic rocks are gneiss, slate, marble, and schists. Now, you may have noticed in learning about the different rock families that all new rocks are made from old rocks. This is the idea behind the rock cycle. For example, Under certain geophysical processes, a metamorphic rock can be formed into a sedimentary and igneous rock. Likewise, all rocks can become every other type of rock given the right circumstances. The rock cycle describes the process that allows the creation of new rocks from old rocks. Next week, we will learn about the rock cycle. So before we end, I'm sure you're probably curious about the image behind me. This is called the Giant Crystal Caverns that was discovered in Chihuahua, Mexico, in an active mine 980 feet below the surface. These giant selenite crystals are over 1,000 years old. The longest one discovered is 39 feet long, over 13 feet around, and weigh 55 tons. That's over 100,000 pounds. That's pretty amazing. Now, as you can see, these scientists down here are wearing specialized suits because the temperatures in this region are up to 136 degrees with over 90% humidity, making it extremely difficult for scientists to study. Now, I hope you enjoyed today's lesson, and thank you for joining me, and we'll see you again next week.